Hello, I'm Tej. I'm back, and today we are going to discuss about fundamentals of C. Okay, today we are going to learn about fundamentals of C. Okay, listen this carefully. Okay, very careful. And first of all, a computer. Computers are very dumb machines. Computers are dumb machines. Did you know that? Computers are very dumb machines. And they do only what you told to do, and they just do what you told to do. Okay, the basic operations of a computer will form what is known as a computer's instruction set. Okay, the basic operations of a computer will form what is known as the computer's instruction set. Okay, and to solve a problem using a computer, you must provide a solution to the problem by sending instructions to the instruction set. If you want to solve a problem, you must provide a solution to the problem by sending instructions to instruction set. Okay, you learn here the instruction set means the basic operations of a computer will form what is known as the computer instruction set. The basic operations of a computer is called instruction set. See here, if you want to solve a problem, and you should first provide a solution to the problem and by the sending instructions to the instruction set. Okay, this is the instructions at how you use the instruction set in C program. Okay, and next, a computer program sends the instructions necessary to solve a specific problem. A computer program sends the instructions. It's gonna send the instructions to solve a specific problem. Okay, which you give later. See, you are just sending the instructions to the instruction set that's the use of to solve a specific problems. Okay, that's used to solve a specific problems. And next, see here, the approach or method that is used to solve the problem is known as an algorithm. A method which is used to solve a problem. Okay, the method which is used to solve a problem is known as algorithm. Did you understand? The method which is used to solve a problem. Okay, so the example, if you create a program, okay, the program is to test that if the number is odd or even. Okay, if the program which you create will say you the number is odd or even. Okay, odd or even. And next, when you enter that number, it will find that you created that the program which finds the odd or even number that was created by you. If that's an algorithm. It's a statement which that's gonna find that the algorithm will find that the number is odd or even. This is algorithm. A statement that solves a problem. Okay. See here, the approach or a method that is used to solve the problem is known as algorithm. Okay. Keep it in mind. To write a C program, you need to write the instructions necessary. To write a C program, you need to write instructions necessary. It's very important to write instructions. Okay. To implement the algorithm, you should write the instructions necessary to implement the algorithm. Okay, and next, these instructions would be expressed in the statement of a particular computer language. These instructions are not similar, but they are different, but they are similar. The uses, and there are some particular languages. We use this instruction in particular languages such as Java, C++, C, Objective-C. These are the computer languages, and we need to express these instructions. Okay, and next, the terminology. We are going to know about this basic terminology. Okay, CPU. CPU means central processing unit. Everyone knows it. CPU is the brain of a computer. CPU is a brain of a computer and does most of the computing work, and it does most of the computing work, and instructions are executed here. The instructions given by you are executed here in the CPU, and RAM means random access memory. Okay, here is a memory. Memory and the hard drive is not similar. Okay, the memory and hard drive are not similar. RAM means random access memory, which stores the data while it's running, while the application is running. It only stores the data while the application is running. It's also a primary memory. If you shut down your computer, okay, if you turn off your computer, or else if you shut down your computer, the RAM will lose the data which it stores. It only stores the data when the application is running. Okay, see, stores the data of a program while it's running. And next, hard drive. Hard drive is a permanent storage. See, stores files that contain program source codes and everything, the application source code, or else even while the computer is turned off, it will store files that contain program source codes. Even while the computer is turned off, it will also store the data after the computer turn off. But in RAM, it only stores when it's running. If you turn off your computer, it loses its data in RAM. Okay, and next, operating system. I think everyone know the operating systems, and it's the operating system is used to increase the convenience to use a computer, or else Android devices or anything, to use a mobile or a computer. Okay, mobile also a computer. Okay, and this operating system developed to help make it more convenient to use computer by the user. Okay, the operating system is a file, it's not a file. Okay, it's a program. Operating system is a program that make a more interaction between a computer or as a system and a user. Okay, a program that controls the entire operation of a computer. It will control the entire operation of computer. Okay, example, if you're gonna uninstall an app, okay, in your mobile, if you are gonna uninstall an app, example, we are going to uninstall some app XYZ. Okay, I just click on it and uninstall it. If you are in Linux, if you are a Linux user, you should go and type some commands. Remove rm and the app name. You should enter like that. If you enter rm and the app name, it will remove it. Okay, they are making the more convenient to use a computer or the systems. Okay, examples: Windows, Unix means it's a Linux operating system, and Android, and more like Mac. Okay, and fetch or execute cycles. Fetch or execute cycles are known as life cycles of CPU. Life cycles of CPU is called executive cycles or fetch cycles. Fetches an instruction from memory and executes it. Okay, we'll show it in next page. And a gigahertz CPU can do this about 1,000,000 times a second. If your CPU is gigahertz, if you add it, it can do about 1,000,000 times a second. Imagine if your computer, what the files your computer is running, it just do 1,000,000,000 times a second. You can't imagine what's going on in your computer in background. Okay, and next, it's a fetch and execute cycle. I told you here. I told you in previous page. And see here, this is the fetch and execute cycle. And you can see there, first, the control unit will execute the file, which if you want to execute any file, it will execute. And the ALU, algorithm logic unit, will fetch by using in RAM and registers. And it's a loop. It's a loop cycle. it will continuously going on. Okay, it will continuously going on if you want to execute. Okay, it will decode like this. And next, higher level programming languages. Okay, higher level programming language make it easier to write programs. Yeah, higher level programming languages make it easier. It's very easier to write programs, and it's opposite of assembly language. And the assembly language means a mission language, a language which understand by the mission is called assembly language. And C is a higher level programming language that describes action in more abstract form. And C is the higher level programming language. Okay, it will describe more. It looks like only English. Maximum it looks like an English. Okay, the instructions of a program more look like problem solving steps. See here. The instructions of a program looks more like a problem solving steps. Okay, do not have to worry about the precise steps a particular CPU would have to take to accomplish a particular task. Okay, and next, compiler. What's compiler? Every high level language has a compiler. Okay, compiler means a program which translates the high level language source code into the mission language instructions to the computer requires. A compiler means which used to translate the higher level language to a mission language. Okay, here I will explain you something. And the higher level language means which you are going to type in C language. Okay, imagine it as a C programming. Imagine the high level language is a C programming. Okay, and next, the mission language. The mission language means it's a binary language which only in 0 and 1s. Okay, this is binary language, 0 and 1s. It only contains 0 and 1s. And the compiler compiles the program and it translates. Okay, example, if you are in Hindi, if you know Hindi, okay, the opposite guy knows Telugu. Okay, you go to Google and translate your language into Telugu. Okay, like this it will the compiler translates the higher level language to a mission level language. Okay, mission language instructions. And next, the program does the high level thinking and the compiler generates the tedious instructions to the CPU. The high level language, the compiler generates to the tedious instructions to the CPU, and the compiler will also check that your program has valid syntax for the programming language that you are compiling. That means your compiler gonna check that there's any errors. If there is any errors, it will not, the executable file will not generate. Sometimes it can't infer the mistakes. Okay, it will only infer the mistakes like is all common mistakes. Okay, in last video we discussed about it. And here, next, high level languages are easier to learn and much easier to program in mission languages. Okay, high level languages are easier. High level language is not easier. It's very easier to learn and much easier to program in then a mission level language. Okay, and next, C. This is the way to write a program. Okay, this is the way. First, you need to keep this all keywords in your mind. Okay, multiple steps. First, define a program objectives. You need to discuss about the program, that what you are going to do, and you should need to think about it more. And next, first design the program. You need to design it. You should need to imagine how would be it, what we are going to do in that, like that. And then next, write the code and compile it and run the program and test and debug the program. Next, maintain and modify the program. We discuss about the steps in next. See, first define and program objectives. This means understand the requirements of the compute program. Okay, first think about the requirements that are going to need for your program. Like if you are going to make a voice assistant, you need some audio requirements like that, mic something like you need to need some requirements like that. Get a clear idea of what you want to program to accomplish. Okay, get the clear idea of what you want the program to accomplish. And next, it's very important. First one is very important, and next one, design. Okay, design. Decide how the programs will meet the above requirements. What should the user interface be like? And the user, you know about user interface. If you are going to open the WhatsApp, you see there's an option, the names of your friends which you started recently in order. Okay, and above it will show the WhatsApp logo and charts, and beside the charts it will show the statuses, and beside the status it will show calls. Okay, in front it shows a cam symbol, and like this you need to think about user interface and how should the program be organized. For in design, you need to, these two are important, these two are very important. Okay, and next, writing the code. Start implementation. Translate the design in the syntax of C by using compilers. You need to use a text editor to create what is called a source code file. No need to use a text editor. You can also use text editor means in notepads or just notepad plus like this. You can also use the IDE platforms. I will show how to install it. It's a code blocks example. It's a code blocks like that. And next compile, and that means to translate the high level languages into mission language. Okay, this means source code into mission code. It means executable code. Okay, it will form an executable file to open your application. Consists of a detailed instruction to the CPU expressed in numeric code. Run the program. Okay, you should run the program, and then the executable file is a program you can run. Okay, it will form a ex.exe file and you can run the program. And next, test and debug. Just because a program is running does not mean it works as intended. That means if your program is running, that means it's not working fine. You should find the bugs, something like that inside. Okay, and this is a main process. Debugging is the process of finding and fixing program errors. Making mistakes is a natural part of learning. And next, maintain and modify the program. This means programs are released and used by many people and have to continue and fix new bugs or add new features. This means if you are a Windows user, okay, if you are a Windows user, or else if you are an Android user, if you are a Windows user, you will get the updates. You will get updates because of if there is any bugs, and if they are going to do any improvements in security or else privacy like that, they will give some updates for you. In Android, they give some updates like that. You should need to maintain your program correctly and neatly. For the above steps, you may have to jump around steps and repeat steps. Okay, except when you are writing code, you might find that your plan was impractical. Okay, no problem. And next, see here, some programmers who teach you in YouTube will ignore these steps first and second. That means what we are going to do, listen to that in the program. Okay, and I told you that the first and second steps was ignored by the programmers who learn you in YouTube. Okay, they just ignore the steps. That's okay, that's fine, but that's not good for larger programs. It's a major mistake for large programs. Okay, but it's okay for very simple programs, but it's very big mistake for larger programs. Okay, the larger and more complex the program is, the more planning it requires. If your program is very complex and very big, you need more planning. Okay, should develop the habit of the planning before coding. Okay, you should need to develop the habit to plan before your code. If it even be a simple code, just plan about it. What is the requirements for it, like that. Okay, and also when you're coding, you always want to work in small steps and constantly test. When you're coding, you need to test it simultaneously in between, because if you complete the whole program, if there is any mistakes in mid of your program, then it's very tough. Okay, you need to solve it before. It's very important. First divide your programs and compile it. If it works, it's fine, but open the exe file and see there. If your program opens, that's not it's working fine. Okay, just go and see the bug, if there is any bugs or like that. And okay, please don't forget to subscribe and share to your friends. And don't forget to share, please subscribe. If you didn't subscribe, just click on subscribe button and turn on your notifications, and you'll get the video instantly when I upload. Okay guys, bye bye. Don't forget to subscribe.